Hello everyone, welcome back to the 5.5 and then today we're going to talk about money unit cost. So unit cost is depreciation and recurrence relation as well. So let's have a look at the unit cost, depreciation, and recurrence relation. So in the Vn plus 1, we have equal to Vn minus d, which is we're using the flat rate. And now what we do is d is a depreciation output. So what we actually means, like these examples. The motorbike purchasing the $12,000 and depreciate the rate of the $14 per 100 kilometers. So set up the recurrence relation to representing the depreciation. That's what we have for the period 5.3. Vn equal to Vn minus d. Sorry, Vn plus 1 equal to Vn minus d. And V0 equal to $12,000. And d equal to 14 per each 100k. And that's how you're depreciating. Now we're going to using the table to find out the 100k, 200, 300, and to 500. So what we do is we're just adding the hundreds basically. So the distance to start with like $12,000, and then once you're adding the $100 kilometers, not $100, 100 kilometers, okay, your future value will become the 12,000 minus 14, which is the 11,986. 200 later, which is you using that to minus the 14 again. So after the 5 times, which is your final 500 kilometers will be equal to 11,930. So using the table also you can use the calculator to calculate these kind of questions. Another question which is we're using taxis. The taxis which is board is $31,000. And 28.4 cents per each kilometers driven. After the 1 year, so the drivers drive the 15,614 kilometers. So we're going to find annual depreciations for this particular year. So first thing first, we need to find out how much the total depreciation money is equals. So we're using total distance to multiply by each kilometers been driving, which is 28.4 cents, which is $0.284 to multiply each other. You will find the annual depreciation year. And then you after that use for to fit $12,000, which is using cell functions. What we do is the total depreciation, which is equal to 31,000 to minus the $12,000. Why we minus the 12,000? Because it's a scramble value. So scrap value, which just means like your useful life is like after the 12,000 comma. So what's the total value right now? And then after that, so what we have is you are being depreciated $19,000. And distance is total depreciation divided by the unit cost, which is 28 cents point 4, which is that will be your unit cost. Total is 19,000 divided by unit cost will be 66,901 kilometers when you drive. So that's how you calculate how long you've been driving and useful life to go into $12,000. Yeah. This kind of makes sense. Hopefully, this actually useful for you guys to put into your band reference. Let's have a look at the other questions. Sorry. So we have photocopier, which is we have $10,800, rate of 20 cents each 100 copies made, and $500,000 of copies are made for a second year. So the first year is 500,000. Second year is 550,000. So depreciation for first year, which is 20 cents multiplied by 500,000, which is $1,000, is the depreciation money. Second year, which is we're using 5,500,000, which is actually that one. Sorry, missing the zero, and then to multiply by 20% again. And we will get is equal to 1,100. So total depreciation, which is 2,100. Then the final value will be from that to from the initial money to minus the depreciation money total will be $8,700. That's the manually doing that for the general math. But you can use a class all the time. If I say, you're probably gonna use a lot of calculator rather than just handwrite it. That could help you guys, and then we can move on to the unit cost for the n outputs, which is we're using v n equal to v0 minus n times d. So for this question, I want you guys to have a look that we have a vertical which is at 27,850 and a value which is 5,050 cents, $5,050. Replace that traveling which is 80,000 kilometers. Now we're gonna try to find a depreciation rate, dollars per kilometer, and for this question, what we need to do is we need to find a total depreciation. You know the 27,850 and the square mile value now is 5,050. That means you depreciate the money is 22,800. Depreciation rate equal to total depreciation divided by total distance, which is 22,800 divided by 80,000 kilometers. That means 28 cents per $5 per each kilometer. So it's kind of reasonable, I would say. Let's have a look at another one. Year depreciations, which is what we're using, is the question be asking you. You have 16,497 kilometers were traveled, and then that's the year traveling to multiply by your rate. That will be your total year depreciation. That's why we multiply by 28.5 cents. You got the 4,701. And the question C, which is we're using set up in the equations and to determine the value of the vertical after traveling n kilometers. So once you have v0 and what we're gonna have is so we have the initial money, which is 20,850, and to see what's going on to each year being like depreciated, which is 27,850 minus the 0.285 and multiply by how many n's we have, so which is we don't know the periods. So this is pretty much what we have. And then they ask you when we're gonna be traveled 80,000 kilometers, sorry, 60,000 kilometers, what's your initial value looks like? That'll be equal. And you just substitution into your recurrence relation, and you will find your final values. Turns out we can creating the calculator as well. Using the calculator to create your values, to use the exam questions sometimes. And I could show you how we're gonna using that, and also let's give a go if you want. So let's have a look at the first question. Hopefully that could help. So first question, the $12,000 and depreciate the use of the unit cost methods, and 0.05 per each cup of coffee made. Um, and we have the recurrence relation, and also calculate the numbers of cups will be made per year. So once you have this question, and don't panicking, you just try to figure out which means, like what's m0, what's mn plus 1, what's mn, or what's that 1440 means, and then that should help you guys to understand more. Um, so for this question, the start beginning, I will say how many cups you been made per year. We know this is the depreciation money, and we know the unit cost, which is the 0.05 per cup. So each year you was getting depreciated like 1,440, but 0.05 per cups. How about we do a dividing things, which is like total depreciation divided by total and unit cost equal to total cups you make. So which means 1,440 divided by 0.05, that will equal to your how many cups you made per year. Hopefully that kind of makes sense. And then we're using recurrence relation to find the coffee machine depreciating the flat rate. And what's the annual flat rate percentage of the depreciation to represent it? So we're using M1 equal to M0 minus the 1,440, which is the 10,560. So why we need this? Because that's how you actually calculate it as you're producing the machine to become the after the 1 year. And then we need to calculate it. What's the annual flat rate, which is each year your flat rate divided by your initial money equal to your flat rate, which is 0.12 multiplied by 100% is 12%. Yeah. Hopefully that kind of makes sense. And then next one, which is we can creating using the MA equal to $12,000 and 0.12, which is use the 0.05 and negative 0.05 because you are dividing each cups to see how many cups you made has been produced. So which is each cup is 5 cents to multiply by how many cups you made. Yeah. All right. Anyway, next question. So what we do is highlight all these numbers you had and to figure out what we need to understand. So after 3 years depreciation and a fourth year under the unit cost, which is 15 cents per kilometer, the value after travel to $30,000 the fourth year, which is equal to 26,166.24. So we need to figure out the depreciation first. The depreciation equals. So depreciation equal to 30,000 multiplied by 0.12. That equal to $4,500 in total. And also what we know is we can use 45,000 to multiply by 1 minus R divided by 100. So why we need this? Because this is a unit circle and we're using the reducing balance, the data we have. And once you have that, you need to calculate it to the power of, which is pretty much like we have is 3 years. So that equal to um, what's the money we do have is equal to $45,000 to minus 26,166.24. Why is minus 0.24? Because 26,166.24, that means it's after the fourth year. That's why we need to minus that. Because minus that is equal to the third year equals. And so now what we do is we need to figure out this K now. So not N, sorry, this K, not R. So we put into the solve function. $45,000 multiplied by 1 minus K divided by 100 to the 3 equal to 66. I would say 74 or 64 or 24. Sorry, 24. Yeah. And once we have that, and we can actually figure this out with your money we have is to figure out the K approximately equal to the 12, and then that's your 12%. Hopefully that kind of makes sense. That's why we do one more, and then finger crossed you understand this one as well. So highlight all the numbers we have: purchasing, the produce that items per each year, and reducing balance, depreciation, and the value machine is 18,480. So now we're gonna find out the total depreciation. We didn't know the total depreciation equals after 3 years. Sorry, after 3 years, we don't know. So 30,000 minus 18,480. So that's the depreciation total. So that equal to 11,520. And depreciation per year, we don't know, so we're using that to divide by 3. So that equal to $3,840 per year. So unit cost, we don't know the unit cost, but we're gonna try to figure it out as well. Equal to 40 divided by the total items we have, and that will be equal to 0.16 per item. And then V annual equal to, so we need using the 0.16 per item, the unit cost, to equal to 30,000 minus 0.16 2 times N. That's your final answer, E. So you always need to find the unit circle first, and once you have that, you should be able to understand how to calculate the rest. So this is all the chapter 5 we have been doing so far. All makes sense. Hopefully that all makes sense a little bit more. I will see you guys in chapter 6, which is we're going to start with compound and simple interest.